everyone, and welcome back for now part 4 of these homework problems, the solutions for these practice problems here. We are going to move on basically to the next kind of problem that we're going to be dealing with, which is adding fractions. And of course that's what we've been working up to now. We've increased the raised to higher terms by making the denominators bigger. We've simplified terms. We've come up with these kinds of greatest common divisors and so forth. Here, in order to add fractions, we need to have, of course, a common denominator. And there's this term that gets thrown around, the least common denominator. But the least common denominator is not absolutely necessary for adding fractions. You simply need a common denominator at all, which common meaning like same. They need to have their denominators in common in order to add them. And so what we're going to do first is here adding the mixed number. We've got a mixed number plus a fraction. It doesn't work out too nicely. What I like to do with all of the fraction problems is just to convert everything to fractions. That includes improper or proper, it doesn't matter. Improper may be the case, especially if you're dealing with mixed numbers. Mixed numbers will become improper fractions anyways. And so we want to just convert this to fractions, and then we can deal with the denominators as we get there. So first, this number 4 3/5, we need to multiply 4 times 5, which is going to be 20, and then we add the 3, and they're still going to be fifths, so this becomes 23/5. So basically we are adding 23/5 plus 6/7. Now, one way that you can get a common denominator, just right off the bat, just get a common denominator without thinking about it too much, is you can just multiply together the denominators that you have. And so here, since these denominators, 5 and 7, that's actually going to be our best bet to do it anyways. That will give us the least common denominator, in fact, just by multiplying 5 times 7. We're looking for the denominators to both become 35. So we're adding, instead of fifths and sevenths, we want to be adding 35ths, which we got by going 5 times 7 is 35. So to make the fifths become 35ths, of course we need to multiply top and bottom times 7. To make the sevenths become 35ths, we need to multiply top and bottom times 5. And so we'll be in this kind of a situation. So 23 times 7, this one becomes how much? 161, it seems like. And then 6 times 5 is 30. So now that we have a common denominator, we can just add the numerator. So 161 plus 30, it becomes 191 on top, 191 35ths. And then we're trying to write this as a mixed number. So what happens if we come over here and we do 191 divided by 35? Of course, 35 will not go into 19, so we end up having to go into the whole 191, and it should go into there, how many times do you think? It should go 5 times, but not 6, so it will go 5 times. 5 times 35 is 100. What do you think? 5 times 30 is 150, so then plus 25 more, so 175. We subtract these, we'll get 16. So 35 goes into 191 5 whole times, and then there are 16 35ths left over. And that will be the answer for this addition. Now we're going to have a chance actually to find a least common denominator. We would still have an option for this one. We're trying to add these fractions. We still need to convert into fractions here. Instead of these mixed numbers, we want to get some improper fractions. And so here 6 1/2, you notice 6 times 2 is 12, so 12 plus 1 is 13. This becomes 13/2. We're converting this one. 2 times 7 is 14, and then plus 6 more, so it becomes 27ths. And then this one, 1 times 4 is just 4, so plus 1, so this becomes 5/4. We're actually adding up these numbers. And now we can get a common denominator again by multiplying these denominators 2 times 7 and times 4. That will do it for us. But actually that denominator is going to be larger then the least common denominator that we can get. And actually, to get the least common denominator, there's a little method that we use. It's actually a pretty nice method. We write down these denominators that we have, 2, 7, and 4. We write them down kind of in this little box. And then we want to come up with a number that at least one of these will be divisible by. So we're trying to find, in other words, a factor for one of these numbers. And right off the bat, you can tell that one of them is divisible by 2. Actually, 2 of them are. But we only need to have one of them divisible by that number. It's not necessary that it will divide more. But anyways, if more of them can be divided by this number, it's fine, we will just do it. So here we actually will write down what we get if we go ahead and divide these numbers by 2, where it's possible to do it and get a whole number. So 2 divided by 2 is possible, you would get 1. 7 divided by 2 is not possible, so we would just write 7. And then 4 divided by 2, it's possible to do it as well, and we would get 2 for doing that. And now we're looking at this new list of numbers, 1, 7, and 2. And we ask the same question, is there a number that we can divide at least one of these by? And of course we can do it with 2 again. So 1 divided by 2, we can't do it. 7, we can't do it. 2 divided by 2, we can do it again and we'll get 1. And now with this list of numbers, finally we're almost there. We wonder, can we divide one of these numbers by something? And of course 7 will work. 7 is a prime number, so we have to choose that one. 1 we cannot divide by 7, and 7 divided by 7 is 1, and then cannot do it with 1. And then once we get this row, we are done. We got all 1s, and so basically what we've done here is we have found all the factors that we need to cover these 3 denominators, 2, 7, and 4. We need 2 2s and a 7, so 2 times 2 times 7. This will give us the least common denominator, which is 4 times 7, which is 28. So we can use 28 as the common denominator for these numbers. So for 13 halves, we should go top and bottom times 14. And then the 27ths, we're trying to get 28 on bottom, so we need to go 7 times 4. So top and bottom times 4. And then 4 to get 28, we need to go top and bottom times 7. This will do it for us. And so I'm going to come over onto this side and going to write these down. So 13 times 14, that's a little bit of a tricky one. Of course, 13 or 14 times 10 is 140, and then plus 52 more, so 192. And then, oh, it should be 182, I think. And then, what do we have? We have also 20 times 4 is 80. And then 5 times 7 is 35. And this is going to be all 28ths. And then we just need to add the tops. And so basically we have 182 plus 80 plus 35. So 182 plus, how much? 115. 28ths. And then we can add these up. It becomes 297 28ths. And so here we're going to try to divide this because we're trying to come up with a mixed number again. It's clear that 28 will go into 297 at least 10 times, right? Because that would be 280. So we can give it a shot. 297 divided by 28. It will go into 29 one time. And then we get 1 for that one into 17. It goes into 17 0 times. And then there's nothing else to bring down, so we actually get a remainder of 17. So 10 with a remainder of 17 means 10, and 17 28ths. That would be the answer for this one. And now we're going to give it another shot for adding these ones with crate and barrel. We're trying to add these numbers over here. I want you guys to go ahead. For this one, we're just trying to find a common denominator between these 3. Once we find the common denominator, I think that you can take it from there. We're looking for the denominator that goes between 5, 4, and 8. So if we want to use this box method, I think it's a very nice method. We're looking for 5, 4, and 8. We need some factors for these. Why not just 5 to begin with, because the 5 is there. 5 divided by 5 is 1, and then these we cannot divide by 5. 4 and 8, we can divide them both by 2. And here we're wanting to find, by the way, prime factors. I'm just choosing prime numbers. It can get kind of messed up if we don't use prime numbers. Because here, for example, what if you try to use 8? You could say, oh, well, 8 is divisible by 8, so we could use 8 over there, but 4 is not divisible by 8, so you'd still have this 4. but then the 8 would become a 1, but then you're still going to have to divide by 4. You'd end up with way too big of a number. And so it would defeat the purpose. So here, we're looking for prime numbers that we can divide by here, prime factors. And so we would choose 2. And so here, 4 divided by 2 is 2, 8 divided by 2 is 4. So we can do 2 again, 2 divided by 2 is 1, 4 divided by 2 is 2, and then we can do 2 one more time. And then we will have all 1s across the board. And so 5 times 2 times 2 times 2. This is going to be the common denominator. Of course, trip 2's goes 8, so 5 times 8 is 40. This will be the least common denominator that we're going to go with. And then we have this problem for subtracting. And of course, subtracting, it's almost the exact same as adding. We need to get that common denominator. And here, adding and subtracting are the more difficult operations that we need to do. Because when we're getting ready, which we're about to do shortly in these problems, to do multiplication and division, we do not need a common denominator to accomplish those. And so here, we're going to subtract these fractions by first finding a common denominator. But remember, always this first step, we want to take these mixed numbers and turn them into fractions. And so 12 times 9 is 108, plus 1 becomes 109 ninths. We're subtracting here 4 times 3 is 12, 12 plus 1 is 13, so 13 thirds. 109 ninths minus 13 thirds. Here we can go through this process with the box, but I think that it's possible to tell here what our least common denominator is going to actually be. Because we can keep the denominator of 9. That's a good denominator for us because 3 times 3 is 9. So if we go to here top and bottom times 3, we will get 9 on bottom, so it will go 109 ninths. We're subtracting 39 ninths. And then what are we going to get? We will get 70 ninths. And so 70 ninths, of course, we can do 70 divided by 9. 9 will go into 70 5 times, not 6 though, because 5 times 9, actually wait, it goes more than 6, it almost goes 7 times. And so why don't we give it a shot going into there 7 times. 7 times 9 is 63, then we subtract, we will get 7 again, so it goes 7 with a remainder of 7. And here we're dealing with ninths all the time, so we know we're going to have ninths, and it goes into there 7 whole times with 7 ninths left over, so 7 and 7 ninths will be our answer for this one. So anyway, that does it for these questions. I will catch you guys in the next video.